Assalamu alaikum everyone, hope you're all fine. Welcome back to my channel. In today's video, we'll be doing the binary coded decimal, a topic of computer science 9618 paper 1 A level. So let us start. The binary coded decimal system is a system that uses 4-bit code to represent each denary digit. All right. So in this system, every digit is represented by a 4-bit code. So that means the 0 will be represented as if we take 1, 2, 4, 8, this is the 4-bit. So 0 is 0, 0, 0, 0. 1 is 0, 0, 0, 1. 2 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. 4 is 0, 1, 0, 0. And 5 is 0, 1, 0, 1. 6 is 0, 1, 1, 0. 7 is 0, 1, 1, 1. 8 is 1, 0, 0. And 9 is 1, 0, 0, 1. So this is the representation of all the digits from 0 to 9 in the 4-bit code. So a number, if it will be represented like 24 will be represented by writing 4 and 2 separately in 4 bits. So it means this is 0, 1, 0, 0 and this is 0, 0, 1, 0. So this is 24. All right. So if we take a number 125, or let's do a different 146. So this is basically 6 is 0, 1, 1, 0, and 4 is 0, 0, 1, 0, and 1 is 1, 0, 0. So as I said that 4-bit code, so to represent the 4-bit, we will have 1 byte, and we can't have 1.5 bytes, so we will put 0 here. So this make it 2 bytes. All right. So for that we can represent like this. So this is the representation of a 040146. This is how the binary coded decimal system numbers they are represented. I hope it is clear. Now the next thing in it is that when we represent the number, where are these binary codeds are used and why to represent the numbers separately. So what is the use of BCD system? Basically BCD system is used for the digital, number one, the digital displays. And you know, the digital displays are like the calculators and like the clocks, digital clocks. All right, clocks, the digital one. And to represent the each digit separately, like in the clock, you see that in the calculator in the clock, the numbers are represented like 150.1. The number can be represented like this. This can be the calculator display, and the clock can also be displayed like 2, 2, 1, 5. So these kind of displays, they are basically done with the help of the binary coded decimal. Now, why to use this technique, and why not to use the number system, the whole number system? So basically, the point which is more important to understand the use of the binary coded is that especially the decimal numbers. Decimal numbers, when they are written into the computer, they are actually very difficult to represent. Very difficult to represent in the binary form. all right? And when they are represented in the binary, the computers, they cannot exactly, computers, they can't exactly represent them. So in your class A2, you will learn the reasons behind this. And then there is a topic of fixed point representation. And then there's also the issue of chopping off the fractional parts because of the limited space in the binary. You know, we always have an 8-bit or 16-bit space in the memory. So it is very difficult to represent a very bigger number. And there are some accumulating errors, all right? There are some accumulating errors that are initially negligible, but after a certain time, they become a big issue. So these things you will be studying in your A2. So here you just need to understand that it is difficult to represent a Danry number, and when there are requirements that the number must be exactly the same, like in the finances. In the finances, we need the exact representation. So then we use the BCD system. All right. The exact values are needed, and to avoid any accumulating errors, and so the values related to finances. So for that, we use the BCD system, and the BCD system will let us represent each digit separately. All right. Let's take an example. For example, we have this digit 0.37, and we have to add it, and this is, let's say, dollar, and this has to be added into the 0.94. And technically, if we add these two numbers, what is the answer? 7 and 4 is 11, 1 carry, and 9, 3, 12, and 1, 2, 13, sorry. 12 and 1, 13, 3, and 1 is carried. So here the number become 1.131. This is the right answer. So now if you see, we add them in the Danry system. In if this is done in the binary, now like the 7 is, you know, this is we'll write 7 as 0 1 1 1, and 3 is 1 1 0 0 dot, and 0 is 0 0 0 0, and 4 is now 0 1 0 0, and 9 is 1 0 0 1 dot 0 0 0 0. And if we add them by using, so this is 3, this is 0, and this is the second row's numbers are 4 and 9. So if we add them, you know, the binary addition, 1 0 is 1, and the next one is 1, 1 1 is 0 with 1 carry, and this is 1, and 1 1 is 0 with 1 carry, and 1 1 is 0 with 1 carry, and this is 1, and this is 1 dot 0 0 0 0. Now we are doing this with the method of BCD system, when we separate each digit, and we have treated, in, you see that 7 is represented separate, 3 is represented separate, 0 separate. So all of the digits, they are written in the binary coded system. So when we write this, what is the answer that is calculated? If you see, the number is now 1 2 4 8, 8 and 2 10 and 1 11. So this become 11 here. This is 1. If you see, this is 1, this is 2, this is 4, and this is 8. 8 and 2 10 1 11. And this is 1 2 4 8, and this is, here it is 12.0000. So this 0000 means this is 0. So the answer is not right now correct. At one place of digit it is calculating 11, and on the other it is calculating 12, and third is 0, but the answer must be 1.311. So there is a mistake in these 2 points. So there are two numbers which are not correct. You can see that these numbers are, sorry, so this 12 is not correct, and this 11 is not correct. All right. So what is this error? Basically, in order to understand this error, and before I remove it, I just wanted to make one more thing clear here. And that is that when in the Denry numbers in the BCD system, when we are representing the number, we are given 4 bits 1, 2, 3, 4. So this is 1, 2, 4, 8. So if you see, if the highest possible number which can be represented here is 15. And you know that the number, as we have seen earlier here, the number in the Denry is only from 0 to 9. So the number in these 4 bits 0 to 9 means these these combination, the representation of 0 to 9 is enough in this 4 bit. But when we have 4 bits, 2 raised to power 4, this becomes 16. So basically the spaces given available to us, they are 16, and the one that we need from 0 to 9, we only need 10 from it. So there are 6 numbers which are additional, which are not needed. What does this mean? It means the number, have you seen that the first number represented in this 4 bit was 0000, and the last number was 01001. Above than this representation are all in errors. So how many errors? We need 10, and the total is 16. So there are 6 error numbers that are generated. So what is the binary number of 6? 0110. Now the solution to this error, whenever we get the representation for each digit, the representation, if it exceed 9, then what we will be doing, we are going to add 0110 in it to correct it. All right. So let's do this. Let me remove it. Now what I'll be doing, I'll be adding 0110 here, 0110 here, and you see this number become 1110, 1 carry, 110, 1 carry, 110, and the carry goes here. So here again 10, and then 1, 110, again 1 carry, 110, and after the decimal this 1 goes to the next nibble. So this 1 comes over here. So here we get 1000. Now this is the answer. Now this is 1, this is 3, and this is 1 3. Now this is the, you can see the correct answer. This is how we can use the binary coded system, and you have seen that by doing this technique we have accurately represented the binary the the decimal binary, right? So this was the problem. If it was to be represented, so if this number was to be represented, so in the binary it was actually difficult. So you have seen that that difficulty. If this was to be represented into the binary form, so there was an error. So this error was actually, so when it is, so we have used the technique of BCD system in order to exactly represent this number. All right. So this is the concept of the BCD. I hope it is clear. Thank you. Allah Hafiz.